to talk about irrational square roots. Until now, we've dealt with radicals, which are square roots, that could be expressed as a rational number in the form of a over b, where b is not zero and a and b are integers. But radicals that cannot be expressed as a rational number either have to be rounded or left as a repeated, or we're going to leave them as a radical in simplest form. So they will still contain a radical. That's what we're going to work on. For this section, both 3 and 4 in your book, no calculators allowed for this work. Let's recall that the square root of a squared is a. The quotient property of square root states that the square root of a rational number is equal to the square root of the numerator divided by the square root of the denominator. And the square root of a product is equal to the product of the square roots of the factors. So we went over those on the last video. Now let's put these properties to work with irrational square roots. This is a short video. We want to find the square root of 125. That is not a rational number. So what can we do so that we have an exact representation of that in simplest form? Well, the square root of 125 is the product of 25 and 5. So we've applied product rule. Now let's separate that into the square root of 25 times the square root of 5. The square root of 5 is not a rational number, but the square root of 25 is. The square root of 25 is 5, so we get 5 times the square root of 25. Just a little note on notation. When you have a coefficient times the radical, you do not need to put any sign in between. But when you have the two radicals, please put your multiplication dot in between those. Let's try one more. The square root of 363 times 4. Well, that is not a rational number. But 363 has a factor of 3. So 363 can be broken into a product of 3 times 121, and 121 is a perfect square. You need to be able to recognize those perfect squares. So we change that to 4 times the square root of 3 times the square root of 121. The square root of 3 is irrational. That needs to stay. So we get 4 times the square root of 3 times 11, which comes down to 44 times the square root of 3. And that's really all there is to it. But no calculators on that work.